Hi, everyone, and welcome to today's webinar, Building a Kubernetes CI/CD Pipeline with GitLab and Helm. Before we get started, I'd like to go over a few housekeeping items so you know how to participate in our event today. You should see a box in the upper right corner of your desktop. This is your control panel. You are listening in using your computer speaker system by default. If you would prefer to join us by phone, just select telephone in the audio tab and the dial-in information will be displayed. You do have the opportunity to submit questions to our presenters today by typing your questions into the question pane on your control panel. You may send in your questions at any time throughout the presentation. We will collect these and address them during our Q&A session at the end. I would like to now introduce you to Jordan Sanders and Dan Salas.
Thanks, Katie. So this is Jordan Saunders. Welcome to our webinar. So the name of the webinar is Building a Kubernetes CI/CD Pipeline with GitLab and Helm. Somebody putting this on with Dan Slapolis, like Katie said. So a little bit about me and about NextLink. So I'm the CEO and founder at NextLink Labs. I have a little bit over a dozen years developing software and specifically doing software consulting. So I started NextLink really with a goal of helping companies to write better software and write it more efficiently. And so I'm very excited to put on this webinar because I think CI/CD pipelines and automation are really a great way to move forward in the future. Dan, do you want to give a quick little intro to yourself?
Sure. Yep. I'm Dan Slapelis. I am a senior DevOps engineer here at NextLink Labs. My formal education is computing security, but I'm a very passionate developer and very passionate about cloud infrastructure. And I like to use my background in making all of the things that I develop and deploy up to the cloud, secure and efficient and functional for all of our customers.
Yeah, thanks, Dan. Thanks for that intro. So just a quick overview of what this webinar is going to look like. So we're going to talk a little bit about writing better software, what good software is, and how we go about writing it. We're going to talk about CI/CD, why you should use it, and specifically GitLab's offering around CI/CD. We're also going to talk about Kubernetes and Helm, just a little bit of a high-level overview for those that aren't familiar. And we will end with a demonstration of showing how to utilize GitLab and Helm to actually deploy an application onto a Kubernetes cluster. And then finally, we will wrap up with some questions. So let's jump right in and talk a little bit about the current business landscape. So in 2021, companies are finding the business landscape increasingly competitive. And speed to market is a very important thing, and iterating on a product to make it better is becoming very important. And that's because it's so competitive. But if it takes a while to deploy a product or build a product, companies can quickly lose market share, not be able to address a target client's need, and really just cause some backup. So how companies are responding is they are increasingly using software as part of the solution to their business challenges. Whereas maybe 10, 15 years ago, software may make up 1 to 10% of a company's offerings. Now software is becoming pervasive throughout organizations, and companies are increasingly relying on software to solve their business challenges. And so this is creating a very interesting dynamic where making improvements to the software development process, and specifically to the speed in which software is developed, are really starting to pay large dividends, since it's so much of their business that is dependent on software. And so writing good software becomes increasingly important. And so let's talk a little bit about what it takes to write good software. So we've learned over the years that software is really difficult to get right the first time. So, when I first got into software 10, 15 years ago, it was very common to spend, 6 or 9 months basically writing a design doc for some software, and then go ahead and, take that 6 to 9 months and actually implement it. And in a lot of cases, this meant that the end users of the software were not seeing it until 6 to 9 months. which, in that 6 to 9 months, you could have been going very quickly in the wrong direction. And once the users actually started using it, you realize, hey, this isn't exactly what we expected. And a lot of times in that time period, the requirements had actually changed. I mentioned how competitive things are these days. And 6 to 9 months, the market totally can change. And so what a lot of experts in our field have identified is that it's best to ship products and then iterate on them quickly. And so some of you might have heard of an MVP, a minimum viable product, but this is something that a lot of companies use to essentially get something in the hands of their users quickly, and then continue to make small, rapid iterations on it. And so rapid iteration has become, a big key to deploying reliable software, specifically software that meets its customers' requirements. And so this concept of rapid iteration came about, and we needed some solutions to this problem. So let's talk about if you want to do rapid iteration, what is really needed. And so you need a repeatable process. Previously, companies might have been doing releases every 2 weeks, 4 weeks, 8 weeks, a pretty long cycle. But if we're going to look to deploying software frequently, we need a process that's repeatable, because if you're going to do it, 40, 50 times in a week, you need to be able to do the same thing over and over. So whatever tools are being used for this, they need to be easily configurable. They need to be secure. After all, this is the keys to the castle. And the tool needs to be accessible. So we want to get developers and operations people, your full DevOps team, DevSecOps teams involved in the process. And so the tool needs to be usable by everyone. And so, what is the answer to this need for rapid iteration? And what the market is currently kind of settled on is this concept of CI/CD. So CI/CD get lumped together often, but they actually are two different concepts. And CI/CD stands for continuous integration and continuous deployment. So continuous integration is really a philosophy, and it's what happens after you check code in. It's that first part of the process. So a very common continuous integration pipeline might look like you check the code in. Let's say it's a JavaScript application. You may run a JavaScript linter against that code base, and you may run some automated tests, and then you may build it afterwards or before. Continuous deployment is kind of the extension of that, and that is actually delivering the application to a production environment. So I have a little graphic here that will kind of give a visual representation of this. So this is a very common flow. We have a main branch. This is supposed to represent a Git branch. You may create a new branch. Let's say this is to update a feature. So in this feature branch, we may make some changes and push them up to production. That's where kind of the continuous integration box starts. So when that code is pushed and deployed, a series of tests are run against it, and maybe those tests fail, and you need to make a few more fixes, and then you push those changes again. And you can see in the second time around, the tests pass, and so we deploy to a review app. And this whole cycle is our continuous integration cycle. And at some point, you're going to decide, or the user's going to decide, or the team's going to decide that this set of changes is ready to be deployed into production. At that point, it would be merged, and the team would go ahead and enable the continuous deployment aspect of this, where it actually goes ahead and deploys to production. So this is a really common pattern we see often. It's a pattern we promote, where basically, you have a few branches that may deploy to production, but you have many branches that when changes are made, you're still running your set of tests, you're still running your linter, you're still making sure the builds work. And this just gives you increased confidence that as you continue to build and modify code, that everything is up to your standards. So, this brings us to a tool that does a really great job of handling CI/CD, as well as a number of other things, and that is GitLab. So what is GitLab? So a while ago, GitLab used to be just a remote Git repository, but as you can see from this screenshot here, it's become a lot more than that. And so in an age where we always want to have a single pane of glass view on what we're working on, whether that's monitoring or reporting, or in this case, software development, we have that with GitLab. So you can see GitLab serves as a place to host our code repository, to host issues about a project. We have information about security compliance, as well as the CI/CD aspect that we're really going to be focusing on. And this is a really powerful thing to have everything in one place. It also has a nice focus on making sure the security needs of the product, the issues of the product, the information of the product, and the wiki are all in one place. And so, GitLab does a really great job of being this solution for us as well as our clients. So GitLab itself has a CI/CD product that is really great. And so some benefits of this are that you're able to get automated deployments. So we talked about rapid iteration, and there's really no way to do rapid iteration well without automation. And so GitLab CI/CD, their pipeline feature, functions as the automated deployments part. You're able to really easily enable automated testing and vulnerability scanning, which is a really powerful thing to make sure that you're not putting out code that has stale packages with known vulnerabilities, which could be a liability to your business or your client's business. Provides us with a really easy way to follow along and trace the build process, and able to trace it in a way that can function as a system of record. For those that have, security and compliance requirements, especially, this becomes really important. But also just for companies that are looking to have, increased focus on QA and testing, and making sure that, if a defect is introduced, they're able to kind of go back and take a look and see where that defect was introduced. And the last thing that I think is really important is that you're able to kind of dictate a process with tooling. If you think about how companies are increasingly deploying, many times a day, and in some cases hundreds of times a day, it's really tough to do that in a large, increasingly distributed team without some process around it. And one of the things we love about GitLab CI/CD is we're able to put some controls around who's able to check code into where and when and what happens before that code makes it to production. We're able to do that by defining it in our GitLab CI/CD configuration file, and that makes sure that any process that we've defined as best practices actually get followed because they're being forced at the configuration level. So talking about GitLab CI/CD, they're really built out of two main constructs. And so there's this feature called GitLab Pipelines. This is where all the CI/CD aspects are contained in. And there are two main constructs. So there are jobs and there are stages. So examples of jobs, these are what actually execute. So I brought up that example previously around a JavaScript application, but a sample job might be to run a linter, or to run a series of automated tests, or to build and compile an application, or to deploy an application. Now stages, these are what define kind of how the jobs are run. So for instance, let's take a very simple example where we have basically a build, test, and deploy stage. In that test phase, we may run two jobs, one for the linter, one for the tests. In the build phase, we just run a build job, and in the deploy phase, we just run a deploy job. So an example of this is, in this graphic, you can see that we have, 5 stages defined down here, and that is build, test, release, deploy, and cleanup. And you can see that, the deploy phase has multiple jobs, but this really gives us the ability to sequence our jobs, to have some run in parallel, and to have some dependencies between jobs, which is a really powerful thing in enforcing the process that we'd like to force. Again, some common stages. We're not going to go through all these in detail, but you can kind of get an understanding of, all the things that go into your SDLC can actually be defined as part of your GitLab pipeline, and make sure it fills in any gaps that the actual human interface doesn't handle. When we talk about running GitLab jobs that are scheduled on GitLab schedules, these jobs actually run on GitLab runners. So the runners are what execute the GitLab jobs. So GitLab actually provides public runners, which will suit a lot of people's purposes, but they also have the ability for you to self-manage your own runners, which adds an added element of security, right? As you're able to control which servers or which devices or which Kubernetes clusters these runners live on, and you're able to make sure that they have whatever configuration is needed to fit both your deployment needs as well as your security requirements. But when Dan does the demo later, you'll see that all the code actually executes on these GitLab runners. So leading into our demo, I'm just going to do a quick overview just of Kubernetes and Helm. These are two topics that are very, very large topics, and honestly, we could probably fill a series of webinars just talking about Kubernetes in itself. But I think what's important to know is that Kubernetes is an open source container orchestration system. So when there was a big push to move things to Docker and Docker containers, a few years ago, there really came a need to be able to schedule and kind of make these containers portable. And Kubernetes has kind of filled the gap in terms of making it very easy to have a runtime to actually run Docker applications. And so these end up being defined in Kubernetes configuration files and really define the whole environment. Helm is a alternative. Basically, think of it as a package manager for Kubernetes. So it's very equivalent to Yum or apt or even like something like npm. But these are actually give us the ability to use templates to define complex Kubernetes applications and make it very easy to manage Kubernetes applications and reuse parts of that configuration. So, why do tools like Helm and Kubernetes provide us with some value? So because they are based on a container-based infrastructure, you get a lot of the benefits of containers. So they are disposable, they're very portable, they're forcing us to use immutable infrastructure. So a big problem in DevOps was configuration drift. That shouldn't happen if you're using software-defined Kubernetes clusters and then obviously cloud-native technologies like Docker, Kubernetes, and Helm. These are community-led projects, so we're able to build on the shoulders of others. They're very transparent, they're open source, you're able to see both the source code of them as well as whatever code you're writing. And they really help to make things modular. Like I said, Helm is a template library essentially, and you're able to reuse Kubernetes templates and make very easy updates and keep different environments at parity. So I want to kick it over here to Dan to kind of demonstrate, how we use this in a simple environment. One of the reasons I'm really excited to put this on is we kept running into clients that were having trouble understanding how these things fit together. They're fairly new technologies, so without too much further ado, I want to kick it over to Dan, and he can kind of demonstrate how they all work together.
Thanks, Jordan. 1 second, I'll share my screen here. All right, so hopefully I think everybody can see my screen here. I'm gonna start off by, I'll just go over what we're gonna be doing first, and then I'll just jump right into it. So obviously we're demoing setting up a sample Git project that will be deploying to our pre-production Kubernetes cluster using GitLab CI. So for that, we're just gonna be deploying a very simple project. It's pretty much an Nginx web server, and we're going to be modifying the index.html file because I think that gives us the fundamentals for what you would want to do for most projects that you deploy to Kubernetes. So as you can see here, I just have a blank Git repo, and so we're going to start off by creating our Helm deployment chart. And so with this simple command, we created our basis for how we're going to be deploying to Kubernetes. And so it provides us with a lot of template files. For this example, we won't be using them. We're going to use our own, but these are actually a really great starting point and give us a lot of coverage for how we want our deployment to run. For example, obviously we have our deployment file right here, which is the basis for how our application will actually be running in Kubernetes. And there are tons of variables that they have for us that we can They're pre-populated, but obviously we can change them on our own as well. And it's just a good structure for deploying your own application. And we have our horizontal pod autoscaler, so we can specify how and when our deployment should scale outwards under load. We have our ingress, so we can access the application from outside of our cluster and our service and our service account. But like I said, we're not going to be using these. We're going to be using our own. So I'm going to go ahead and delete all these and actually clear out this as well because we have our own values file. So the next thing that makes sense to start off with is our Docker file. And our Docker file is, like I said, it's a simple Nginx container. So we're going to do from Nginx, and we're going to specify this version. I believe this is the latest stable version. And we are also going to have all of our site content defined in this folder, site content. And this is actually just going to have our index.html file. And so we're going to need to get that file into our container itself as we build it. So we're going to specify where we're going to copy the file from in our root context here. And the folder in which we'll be presenting from is user share nginx HTML. So all the content that we define in our site content folder on the build of the image will be populated into this this folder right here, and we're not going to change the entry point or anything else in here. I'm just going to let container do its own thing. Then after that, we will go ahead and we'll start building out our deployment, our Helm chart here. Because like I said, it's very simple, just an Nginx container. So there's nothing else really to define in regards to functionality. What we have here, if we were to build this container, we would have a functioning Nginx web server that hosts our index.html file. So let's go ahead and create our deployment.yaml file. So in this Helm chart, these are just basic manifest files for Kubernetes. It's pretty standard, but what we're going to be really demonstrating here with Helm is how we can inject our variables into this file to have a dynamic deployment. So this is just basic structure here, nothing really new. But now we're going to reference our first variable in Helm here, and this will be our application name. So we're going to do values.application.name for our variable substitution. I don't know why I just spaced that out. Actually, let me change this. Apparently I don't have my Helm formatter on. Okay, well, let's put it in quotes. All right, so actually I think it makes sense now to go ahead and actually add this file to our values.yaml file, where we will be pulling all of these variables from as we deploy with Helm. So replica count for how many replicas we want our deployment to have, application, and so this right here, this structure, this is how we will be referencing it in our Helm chart. So you can see our values file, application, and then the actual attribute that we're going to be using here is name. And as you can see here, that's exactly what we defined. So that's how things will be. That's how things will show up as we write them. So we're just going to continue through writing the deployment file with all the other attributes that we need. copy and paste some of this so we don't spend too much time just typing, right? It's probably a good idea. So I have this all pre-written out here, and I don't know what this formatting is going on here, but let's not focus on that too much. So as you can see here, this is our deployment manifest, and we are referencing application name a lot here for these just these beginning parts. But then we go on and we specify where we're going to be getting our image from. We define our resources, and this is something I actually want to stress. Something that I want to stress, that whenever you are making a deployment to Kubernetes, you want to define your resources. If you don't, it's, you know, your application will deploy just fine. But as your organization becomes more dependent on Kubernetes and you have more containers and pods running inside of your cluster, your Kubernetes scheduler will run into some issues with the deployments if you don't specify your requests and your limits in your values file here. So you need to, the requests are important for getting the pods scheduled on the right nodes. And then your limits are the max amount of resources that you're going to allocate to that pod, or before it is killed by Kubernetes for using too much resources. And that helps keep things, you know, in a good like homeostasis, keep them running. So we're going to go ahead and define ours here. Although for this, you know, I guess we don't really need it. It's just a simple Nginx server, but something I want to focus on there. So as you can see, we have this whole manifest file created, and we have an image pull secret. Because we are using a private GitLab repo, our image registry is also private. So we will have to have a way for Kubernetes to authenticate with GitLab, the GitLab registry, as we pull the image. So GitLab gives us the ability to specify a deployment token. And I will just show really quick what that looks like in GitLab. So this is our sample repository here, or project. If we go into settings and repository, you can see that we have a section called deploy tokens. And under deploy tokens, you'll see that I created a deploy token named Kubernetes with the read registry scope. And this is all that your token, this is the only access that your token needs in order to be able to pull the image from your private registry. And this ends up as a base64 encoded secret in your secret manifest. Now for this example, we are actually defining the secret file in our Helm chart, just plain unencrypted, just base64 encoded secret. Now that's just for this example, but if you're using this in a production scenario, you do not want to have obviously your secrets just plain text in your Git repo. There are plenty of tools to go ahead and you know, define secrets securely for deployments to Kubernetes. Just for an example, at a small scale, you could use something like Bitnami has a operator called sealed secrets that tends to work out pretty great. You have a controller running in your cluster, and you encrypt the secrets file before you deploy it with the key from that cluster. So only that cluster will be able to decrypt the secrets and produce an actual Kubernetes secret file. So that's a good way to do things. But here, you know, it's just an example, and we're only defining our image pull token. So we just have a base64 encoded here so that our cluster can actually deploy this. So that covered two things there. So we have our deployment manifest file and our secret manifest file. So next, it makes sense to define our service definition. And our service is going to be how we expose our deployment to our ingress. So I'm going to take this file here, paste it in here. So you can see, again, we're referencing several variables. Application port, which we do not have defined yet, which is port 80 because this is a web server. So we are exposing port 80 on the Nginx container to this service. And we'll be routing our traffic to that service port for all of our pods. And then the last thing that we want to define is our ingress. And for this, we are actually using, so our cluster is running in AWS right now. And we are using the AWS load balancer operator to spin up an application load balancer for us on deployment of this ingress file. So you can see here that there's a bunch of things in the annotations that are specific to this this type of deployment. So we have our subnets defined. These are our 3 public subnets for our VPC. So our Kubernetes cluster is all on private subnets, and this will be our bridge through our NAT gateway into our private subnets here for our cluster. And we have our Nextlink Labs certificate ARN right there. And we're listening at port 80 and 443, but we are going to be redirecting all traffic to 443. So we will only be serving SSL requests. As you can see here, we're allowing this to be deployed for any subdomain on Nextlink Labs, and all traffic will be redirected to this Nginx container. So that defines all of our manifest files here, and we can go ahead and just create some sample site content. I have some HTML here to deploy for us. So you can see here, just basic HTML, and just gonna real quick check and make sure these are all the files that we need. Oh, the most important one, the GitLab CI file. How could I forget that? This is the key to the puzzle here for us to be able to actually use our GitLab runner. So I'm going to set up this sample file. So Jordan went over stages and jobs, and this is a good demonstration of the stages and the jobs. So we are defining 2 stages, build and deploy. And we also have 2 jobs called build and deploy. And so this might be confusing, but this is a job, what I have highlighted here, and this is our stage. So under our stage of build, we are running a job called build. And that build is just packaging our image for us and adding it to our registry. So you can see here that we're creating an image name. This is our path to our path to our project, and this is our project, and we are creating an image there. And for our tags, we are going to be using the short version of our commit SHA, and just pushing it to our registry. And then on deployment, this is our very simple Helm command. We're basing it off of our Helm 354 image on our pre-prod Kubernetes runner. So this is a runner running in the cluster that we want to deploy to. And it has some permissions to give it the ability to actually deploy this, just some cluster role. And then you can see here we are running a command here, Helm upgrade sample Helm CI/CD. This should actually be Helm CI/CD demo. And we are going into the deploy folder where our chart is defined. You're installing it if it doesn't exist, which is good for our first run. And then from there, we're going to just be upgrading the Helm chart that is deployed. And we are not defining our image tag within our values.yaml file. We want to define that with each pipeline so that we use the updated image tag. And we're deploying it to our namespace here, and we give it a timeout of 30 minutes. This just so it doesn't continuously run if there's some sort of issue with your deployment. 30 minutes is pretty long, but yeah, you'd want to have a timeout for pretty much all of your deployments. And that is all that we need here to deploy our application to our cluster. So you can see it's very simply our Docker file, our GitLab CI.yaml file, our content, and finally our Helm chart for deployment. And these are all the tools that we need to actually create a deployment. So I'm going to commit this. Let's just call it demo. Deploy. I'll try to switch my window. So you can see here that all of our content is now there, and we are running a pipeline with our build, and it just was scheduled on our runner that is in our cluster. You can see we finished our build, so we should be kicking off our deployment with Helm. You can see that we had an error. I believe that is probably because of this weird spacing issue that is going on here. So let me see if I can fix that. If not, I have a backup that is already working, so I don't know why this is not letting me format.
It's just the law of demos. Could go wrong, will go wrong.
Exactly. Actually, I might just go ahead and just use our backup because that might be a little bit long to do all these files. So anyways, kick it over to the other window where we have actually working deployments. So let's go to that really quick. So this is literally the same project, just the formatting for the Helm variables is actually working. So I'll go ahead and run a pipeline here. Just manually kick it off. It's pretty much the same thing as us making a new commit and triggering deployment. So you can see here we're going to go through our build again, then we're going to go to our deployment. So I'm not gonna really focus too much on the build here, but maybe if it finishes quickly, I can show how quick the deployment actually is, and how this is actually running. Right, and we just got to our deployment steps. You'll see it finish the deployment. Very, very quick here for it to change out our files. And then this is our final running product. You can see this is our subdomain that we're using. So I'm going to go ahead and just make a really quick change to the index.html file and demonstrate, how quickly our change gets deployed to our production environment here. So I'm going to go edit and using the GitLab CI, their little IDE changes. We triggered off a new build and deployment pipeline, and we'll see that change referenced here. So we're going to just get rid of this section.
So yeah, this whole process just really shows you, you can see that Dan's making changes to the code directly, right? And he's about to see those changes manifest in the deployed application, which is really powerful because you don't need to go ahead and actually deal with, you don't need to actually go ahead and deal with the manual deployment process there. You can see it's updating in the background.
Yes, that was the old container going down and the new one going up. So you can see here that we no longer have the viewers section, and we deployed our change into our sample production environment as easy as just a developer making a change to whatever code they want, and almost immediately, I guess, seeing your changes referenced externally. And that is all I have for the demonstration portion of things here. Would be more than happy to answer any questions if anybody has any.
Yeah, thanks, Dan. I just wanted to again just kind of wrap up and say, obviously this is a very rudimentary example, but you can definitely see how we could expand both the GitLab pipeline to do many other phases of the SDLC, but also expand the deployment to handle, a true application, whether that's, a Node application, Ruby on Rails, Django, Go, any really modern programming language, is able to fit into kind of the same tool set and really automate the whole deployment process.
Well, you guys must have done a phenomenal job of going through everything because nobody has submitted any questions. I just want to remind everyone, if you do have a question, just submit it on the control panel in the question tab. And while we're wrapping that up, I'd like to thank Dan and Jordan for their time today in doing the presentation, and as well as thank our attendee for joining us. So I still don't see any question coming through, so I can give about 15 minutes back in everyone's day. So thanks again, everyone, and have a great day. Oh, hold on. Nope, we just got a thank you. So thank you very much.
Thanks,
Have a
everyone.
great
Thanks,
day,
Dean.
guys.
Thank you.